హాయ్ ఫ్రెండ్స్, వెల్కమ్ టు GNT ట్యూటోరియల్స్. ఇప్పటివరకు ఎవరైనా మన ఛానల్ సబ్స్క్రైబ్ చేసుకోకుండా ఉంటే సో ప్లీజ్ సబ్స్క్రైబ్ అవర్ ఛానల్. Okay, please share to our friends also. So this is a concept of integrator in case of the operational amplifier. So generally we know that integrator means in case of the RC network, output taking across the capacitor. So we know that generally resistor we are connecting like this. So this is the RC network. Output across the capacitor is equal to integrator. So generally, if you know the basic concept of the electronics, so this is a basic circuit diagram. Suppose if you are taking this input voltage Vi, so if you are applying the KVL, okay, V naught is equal to 1 by C integral of I dt. So this is a basic equation for integrator. Now let us see how the operational amplifier working condition is going to be there. So in this scenario, in case of the operational amplifier at node A, okay, this is a point of A. So here at node A, this is connected to the ground. So due to this virtual short, VA value is equal to 0. VA value is equal to 0. At the same time, apply the KCL at node A. So apply KCL at node A. Therefore, it is equal to current I1 plus I2 is equal to 0. Where I1 is equal to V1 Vi input voltage by resistance R plus this is equal to voltage across the capacitor. Voltage across capacitor VC is equal to C into dV by dt. So this is the basic capacitor. So where C is equal to CF, for V is equal to output voltage. So voltage across capacitor VC is equal to C into dV by current. So this is a current equation, right? Sorry, this is a current equation. So we are writing the KCL equation, right? So KCL in case of this, so that's why we can write current equation. I will call it dV by. So generally we know that VC, so from this equation also we can write as C into dV naught. Okay, at the same time is equal to I dt. Taking the integration, I is equal to C into dV naught by. So from this also we can get like this. Okay, so from this consideration, where I2 can be represented as CF into d by dt of where V naught is equal to it's a difference of V naught minus 0. Okay, so difference of these two. Therefore V naught minus voltage across capacitor is equal to 0. Now from this equation, Vi minus 0, so we can directly write this one, Vi by R is equal to minus CF into d by dt of V naught. Okay, so from this, taking integration on both sides, taking integration on both sides, we can get what we are getting. So integral of Vi into R dt is equal to minus CF. Integration and differentiation both are cancelled, therefore we can get only V naught. Therefore output voltage V naught is equal to, this is coming to left side, and interchange in the V0 and CF, therefore we can get minus 1 by CF integral of RC into, okay, integral of, I will write R is also outside this one, RCF into VI dt. Okay. Therefore, from this equation, we can conclude that, therefore we can represent V0 is equal to output voltage of the 1 by minus RCF integral of Vi dt. Okay, this is the equation for integrator. Okay, so where from this output voltage is integration of input voltage, so it is called integrator circuit. Okay, I hope this video is very helpful for you. I think you will get this concept very clearly, right? So this is a circuit diagram for integrated circuit. Okay, thank you for watching GMK tutorials. Thanks a lot.